Good morning, everybody. Thank you very much for the invitation from the organization. It's a pleasure for me to be here. In my presentation today, I would like to give you a short overview of the company, to talk a little bit about the design, because after the speaker after me will talk a lot about the design, and the quality control and the quality and the logistic, because we are talking a prefabricated element and we have to go in a practical way to understand how is the limitation in terms of logistic and so on. And after, I give you a few kind of projects just to understand how is possible to do with this kind of technology. Just some example around the world, in Italy, in South America, and in Australia. But the company, we are located in Italy. We are a manufacturer and a builder. And in Italy, we are able to follow big projects like general contract. For this, not only CLT production. In our company, we are able to follow from the design to the build modeling until the prefabrication, the installation, and the building management. Production, how is made and which is our capacity. CLT is mean cross-laminated timber. In our capacity now, in our production now, we have 300,000 square meters of capacity, and we are working on 20,000 square meters of area. Which is the dimension? Cross-laminated timber is mean different board, different lamellas, cross together and glue together. The dimension, for example, my maximum dimension is depending from the press. Different producers have different dimension of the press, and the maximum in our case is 13.5 or 3.5. We are working with European softwood, in particular spruce, like quite all the producers in Europe, and humidity 12%. The certification, we are working with polyurethanic glue without formaldehyde. And the first that I write them is the EPD certification, because before Professor Tuliados was talking about the CO2, okay? But which is the number of the CO2 that you store exactly in my case, in my panel. There is a certification called APD, where an external auditor gives us the number and certify the number that we provide to the client. And the other is the PFC, is that the wood become from a forest that is managed in terms of sustainability. Usually CLT have the layer. The layer could be from 3 to 9 layers. Have to be symmetric, the composition. And thickness, we are talking about CLT 50 millimeter, and the maximum in our case is 360 millimeter of thickness. Okay, the common use for wall and floor is between 100 and 200 millimeter, is maybe the 95% of our production. And how is made? The factory is made all automatically. We start from the board coming from the sawmill already dried. We do the finger joint, we glue together, we put the glue before the glue, and there is a press. In our case, we have an hydraulic press. There is a press, and finally there is the CNC machinery. The CNC machinery is a machinery that cut all the elements, do all the hole, all the installation space to be able to go on building site like a Lego. Building with timber, in particular with CLT, is like to build IKEA furniture, like a Lego. Okay. Design, I go very quickly, because after engineer Franco Piva will explain much better this thing. Usually we start from a beam system model. We do the FM model because Italy have a good earthquake like Greece. We have to choose the right thickness. Different lamella mean different thickness for wall and floors. But what we need to be able to build houses is this one, because we produce a rectangular element and we have to cut in rectangular, triangular, have the space for the beam, have the space for the installation, and the process from the architectural drawing arriving to the production, the final file that we need is this kind of file. Okay, and the process in the middle we'll explain after from Franco. Quality control. CLT is a prefabricated element for building, and all the quality control is made in-house. And the engineer on building side have to ask the daily report control to the manufacturer. What we do in particular, we do the finger joint. Each day we have to do some tests. In our case is 12 or 15 tests, and it's a 4 points bending test in the point of the finger joint, just to understand if the glue is made well, is everything all the day is working well. And we go to through the different failure mode. The failure mode is only glue, the failure mode is in timber, and we go to register exactly the strength of the material. Each day we broke 15, 20 elements, and we go to see what happened. Another very important test is the delamination test, because the heart of the technology, like XLAM and CLT, is the glue. Okay, and the glue have to be made very well. And what happened? We take out, it's an European standard, we take out a cube from the production. Each 2 panel, we have to take 1 cube, usually from the windows, usually from the waste of production. We put the cube in water with high pressure. We fulfill all the grain with water. After go for 24 hours on high temperature machinery, they come back with the humidity. And the final, we broke on the glue line. Open the glue line and look how many percentage of fiber we have, or when this sample is wrong, you have only glue and glue in the 2 faces of the element. In this case, it's a problem. And we give the lamination test report. And when the CLT element, like the XLAM element, arrive on the building site, there is a label. In the label, you can find information about the CE marking, the information, the legal information in Europe, and a lot of other information like the weight, like the dimension, and so on. Logistic. The panel is ready to be shipped on building site. We have to start how we lift and handle this element. Usually, 99% of the case, we use the belt, this white belt. We use this, we do a hole, and we move using this belt. Or, for example, there is a system made from rotoglass, XLAM, where it's a connection system together with a lifting system. Okay, and this is something new we do to building with this kind of product. Tracks. There is different kind of tracks. How can I upload the panel, and which is the maximum dimension that can I use with this kind of transportation? For example, in this case, there is a particular track where we can transport 3.3 meters until 12 meters vertically. Or in this case, it's just normal, 3 meters for 12 meters vertically. This is or horizontally. Usually we made already 2 projects here in nearly Greece. And in this case, the dimension is the dimension of the tracks, that is 2.4 meters usually, for 12 meters or 13 meters. But the dimension has to be 2.4 meters because you pack horizontally on the tracks. Or you can store vertically but covered. Okay, and in this case, using this steel element in the middle, you can arrive until 3 meters, 3.1 meters. And this is an example. For this, different tracks, different logistic system, it means different size of the panel. It means we have to do the engineering taking in account the logistic issue. And we don't have to forget the logistic issue. For example, when we go around the world, we use the container. The door of the container is 2.35 meters, and the length has to be less than 12.00. This year we do a big project with 12.00, and we discovered that the internal part of the container is 12.03. There is 3 centimeter space to put in the 12 meter, exactly 12 meter elements. Or, in some case, we already do a building, helicopter. In the mountain, we are living in the Alps. When we build a building in the top of the mountain, we use many times the helicopter. In this case, the helicopter, depending from the kind of helicopter and where is it, and the weight has to be precise. So we cannot take only the average density of the wood. Usually we take all the panel, we put, and we give exactly the weight, because without, the helicopter can have problem. Okay, different project that we made, and I explained to you what is the difference. Just I want that you understand the potential of this kind of technology. The first, made 3 years ago in city center of Chioggia, is a 7-floor building, okay, in a completely city center. Chioggia is like a small Venice, it's very nearly to Venice. And in this case, what is the particular thing? Completely city center, no logistics space, and a lot of people around that they don't want to have noises during the work. Doing a building like this, 3 people, 1 floor each week, only using a drill machine and nothing more. For this, when you go in the city center, using this kind of technology can help a lot in terms of logistics, in terms of noises. And after earthquake, fire, all the advantages that you spoke before. This is, for example, an extension made in Rovigo, the last floor made by CLT. In all the cities in the world now, the CLT, the mass timber, is used a lot to extend the existing building. Okay, because it's light, because it's fast, and because it's clean. This is an office building in Reggio Emilia. It's a 7,000 square meter of office building built inside an existing old factory. Okay, and with the wood, with some logistic problem, wood using steel together, because it's not never wood is only wood. Some steel element usually we need it, and this is another example of application. Military buildings. 3 years ago, we made the first Italian military buildings made by CLT. We are in Grosseto, nearly Florence. Shopping center. One of the business of our group is shopping center. This is a shopping center, but made using concrete columns and all the other things made by timber. For this, we don't have to have in mind only timber, because we have to use only timber. In the case of shopping center, concrete columns make sense because you have more flexibility in terms of space, in terms of internal distribution. And this is one. Care homes. We made many care homes in Italy. Care homes is very good timber for this because it's very fast. Usually care homes is very modular building, and using timber in this kind of building, we have a lot of advantages in terms of time and cost. This is some example of care home. School. In Italy, a lot of school is made by timber, using timber. Normal residential building. This is Florence, 5 floors building. And a lot of villas. A big part of our production is going to build villas. And this is some example, but it's normal villas made by CLT and not by concrete or other. Here we are in South America, Uruguay. It's a touristic resort. In this case, the client choose the timber only because the time. They start to build in May, and they go to open December, same years, the new hotel. For this, the timing was very important in this case. All the transportation was by container. Student accommodation, Australia. We made many projects in Australia in student accommodation, And you have to think the panel from Italy went to Australia. For this is very easy with this technology to build around the world. This is the first passive house student accommodation in the South Hemisphere. Okay, some image of this building. You can see the prefabricated bathroom, because student accommodation is similar to the care home, the architecture. And here you can see this kind of building as the finished rooms using visual grade panel. CLT you can live on visual if you want. And some view of this point. Another student accommodation. This one, it was 650 student accommodation in Melbourne. The design and the production installation made from Italy. And this case is like before, prefabricated facade, and very easy, and they built this in less than 1 year. Another application, before we have seen swimming pool, a lot of good swimming pool. This is a paint shed, nearly to the sea. It's a very particular glulam structure in this case. And this glulam structure is very big because it's 30 meters high, this one. And you have to understand that this boat go into this building during the winter time for painting, for maintenance, for this kind of job. Other student accommodation in Rome is a student accommodation with the brick outside, and you don't see 1 centimeter of timber, but it's made by timber. Only just to show you some example. For example, our history, my personal history in multi-stories building in the last 10 years, but the history that I made, that was made from a lot of different producers of CLT in the world. I remember in 2010, 2013, the first 5 floors that we made, it was unbelievable, 5 floors timber building. After different project, now the 5, 6, 7, I think that we made 10 per year, or 15 per year. And during the first storm of COVID, we made the Italian's tallest building in Loreto, 29 meters high, without using steel and concrete, only timber. This is made only by timber. Some numbers about this small tower, because in US and in Norway they made tallest building, but in Italy this is a good example. And some picture, the prefabricated stair, for example, how we connect all this building down. Already collaborated very strong strong collaboration between the concrete builder and the CLT producer and installer, and some picture. But you have to think that during the first storm of COVID, this building was made with maximum 5 employees on building site, 1 floor each 6 working days. For this, in 11 weeks, all this building was installed. When we talk about fast, CLT is a fast system. Okay, in 11, yeah. And this is the finish. Just the last 3 slides, and I finish. What we are doing now, we are now finished a project in Spain with Norman Foster architect. It's the first project from Norman Foster made in timber. In this case, it's a very particular office building inside an existing building. All the columns and all the beams are made by chestnut for this European hardwood. Okay, and the CLT was made by all the visual CLT, and the visual face was made by white spruce, because the architect Foster liked more white spruce than the red spruce. Another one is a multi-story building, very simple, in Trento. Nothing in particular that we are on the building site. And one of the last is a very small residential building. This one is nothing in particular, but the location is beautiful. It's the Garda Lake. We are nearly to the Garda Lake. The location is beautiful. I show only this picture because the location. And this is the London market in the city center of London. We did the installation last year. And London market, Blulam and CLT building. Now we are supplying this, the Murdoch University in Perth. This is 150 meters long. It's more or less 3,000 cubic meters of CLT and 3,000 cubic meters of glulam. And this is a great project that we developed during last year, and we sent the last container last week. And this is finished. It's a very good project. Thank you very much for your attention.